Hi everyone, my name is Vinila Nalla and I'm currently pursuing a master degree in information technology with a specialization in data analytics. Today I'm excited to present my poster on comparative evaluation of EMBED dataset for mammogram classification using deep learning techniques. I'm very much eager to share my work with you all. As we all know, breast cancer is a global health concern for women. The detection of breast cancer in its early stages is crucial, and screening mammography serves as a vital leading edge tool for achieving this goal. While various imaging techniques such as CT or MRI, ultrasonography are employed for the diagnosis of breast cancer, mammograms have demonstrated exceptional results in reducing the risk of breast cancer. Even though it is highly used, the complexity of mammograms and the high volume of exams per radiologist can lead to false diagnosis, right? So this is where the computer aided diagnosis systems come into play. They use image processing techniques to aid radiologists in detecting and classifying breast cancer. So in this study, we aim to investigate whether the classification performance for breast cancer screening can be improved by a deeper neural network based technique. We proposed method which utilizes machine learning techniques to automate the image analysis process. To evaluate the performance of your approach, we conducted experiments using the EMBED breast imaging dataset, which is also called EMBED. So this EMBED contains very unique and comprehensive coverage of mammogram images with diverse characteristics. In conclusion, EMBED contains over 3.4 million mammogram images from 200k individuals with 40,000 annotated lesions and diverse racial and ethnic populations. The dataset also includes annotations for various blood densities, lesion types, and sizes, making it a very ideal source for testing and validating the effectiveness of our proposed method. We believe our study is significant as it is to train a breast cancer screening model using the comprehensive diverse EMBED dataset. The use of this dataset highlights the potential impact of our research, and we believe that the vast collection of mammogram images in EMBED combined with our use of advanced machine learning techniques underscores the potential of the model for accurately classifying mammograms. As there are main questions to be raised and we are happy to answer, we aim to mention these research questions in the study which mentioned in the poster. Coming to the methods, as we mentioned, EMBED dataset is a valuable dataset for developing CAD systems for breast cancer in diverse population. And it also contains bi-rate labels which we can see in the table 1, and it also contains the location number where the exams have conducted. So we took the location number and extracted the datasets based on that location number, which resulted in 2 more datasets to run our model. And we can see the overview of methodology used in the methods section of the poster, where we took bi-rate 0 cases as a positive and bi-rate 1-2 cases as a negative. And we can see the bi-rates description for the table 1. And the sample mammograph for the positive and negative bi-rate 0 and 1 and 2 can be seen in the sample mammogram of figure 1. We divided that into 60, 20 and 20 is to ratio of training, testing and validation datasets. So as I said, we are running a deeper neural network methods. So we opted for the ResNet 50 and ResNet 152 models to run. While coming to the image processing, we resized is the maximum of 1920 and 1080 pixels of the mammogram, and batch is processed to batch size of 6. We used a TensorFlow dataset format for the datasets we used. And we used 20 epochs as a training, and evaluation metrics is calculated using accuracy, AUC, precision, recall and F1 score. We can see the architecture in the figure 2 mentioned in here. And after running model, the results resulted as ResNet 152 V2 model achieved slightly higher recall scores than the ResNet 50 V2 model, suggesting that it may be better at distinction between true positives, because recall considered as an important metric when it comes to the cancer screening. There were some differences in the F1 scores, precision and recall between the two models which can be seen in table 2. And the graphs between the scores mentioned in the table 2 can be seen above the table 2 as well. In conclusion, the results showed that the both models performed similarly when trained on all attributes. However, when trained on hospital-specific data, ResNet 152 outperformed ResNet 50 in terms of recall score for all the hospitals. The findings suggest that the use of deeper layers can improve recall, which is particularly important in cancer screening. It is recommended using models with more layers for the larger dataset, as ResNet 150 consistently achieved higher recall scores in this study when run multiple times. And I want to acknowledge my advisors, Dr. Minje Wu and Dr. Sandran Pauriha, to give, as they have given the constant support for me throughout the whole work. And here are the references that mentioned here, and thank you for this opportunity, you all.